One of the benefits of bringing big data and relational data together in SQL Server 2019 Big Data Clusters is that it makes it faster and easier to process all of that information for artificial intelligence and machine learning applications. Beyond just providing the tools and systems required to ingest, store, and prepare data for analysis, big data clusters also include the tools required to train machine learning models, store the models, and to operationalize their results by sending information back out to connected applications and business intelligence dashboards. The cluster does this by improving the outcomes from artificial intelligence and predictive analytics by streamlining the 4 V's of big data: volume, variety, velocity, and veracity. Volume refers to the quantity of data collected. Big data clusters increase the amount of data available for artificial intelligence by leveraging the scalable, inexpensive data storage of HDFS. With more data available for processing, AI models can make better predictions. Integrating data from multiple sources produces a wider variety of information, the second V of the 4 V's of big data. A wider variety of data also leads to better predictions. Big data clusters increase data variety through Polybase connectors to data residing in external databases and big data stores. The third V is for velocity. With the addition of Apache Spark to the big data cluster, information can be processed quickly. And with Kubernetes managing the nodes in the cluster, elastic compute and caching resources can be brought online as needed to maintain a consistent level of service. This increases the capacity of the cluster to provide real-time predictions, which require up-to-date data flowing quickly through the pipeline. And finally, that brings us to veracity. Veracity is a measure of the quality of the data that's fed into a predictive model. Higher quality data yields higher quality predictions. This removes latency and quality issues that arise from information being out of date by the time that it can be processed by the machine learning model. So that's how big data clusters affect the volume, variety, velocity, and veracity of the data that can be processed through the artificial intelligence and machine learning data pipeline. Here's what the full process looks like. Structured and unstructured data is brought into the cluster through Spark streaming, direct writes through the HDFS API, or through T-SQL insert queries. The data is stored in HDFS or in the SQL Server master instance in tables, graph, or JSON or XML formats. Data is then aggregated and transformed using T-SQL or Spark. This processing step can be accomplished through SQL Server's machine learning services and running R, Python, or Java modeling scripts, or through Apache Spark leveraging all of the open source libraries that those languages support, such as TensorFlow or Caffe. Finally, the models can be served through the SQL Server master instance using stored procedures or REST APIs, and be integrated with external applications and business intelligence dashboards. All of these steps, ingestion, storage, prepping and training the model, and making that model available to applications, all of that happens within the big data cluster. Once brought in, the data never has to leave the security and compliance boundaries of the cluster. This makes a big data cluster ideal for security-conscious organizations that need to maintain tight controls over the information that they collect and use.